Hello everyone, so in this video we are going to discuss about the system property of time invariance. The property is quite understandable by its name itself, but we will also define it. So conceptually a system is time invariant if the behavior and characteristic of the system are fixed over time. So they must not change with respect to the time. So this is the basic definition of time invariance, and to understand it, suppose we have a circuit in which we have a voltage source, and suppose we have a resistance and a capacitor, and suppose these R and C values are fixed and they will not change with time. So suppose we do some experiment on day 1 and again repeat the experiment on day 2. We would expect to get the same result on these 2 days because we have said that R and C values are fixed and they will not change. So this is the notion of time invariance. So the results are not changing in both of the days. But suppose the values are not fixed and R and C is changing with time. So they are changing with time. So then what will happen? The results on these 2 days will be different. And that will be an example of time variant system. So this is a very basic definition of time invariance or variance. Now we'll discuss in terms of signal and system. So in terms of signal system, a system is time invariant if a time shift in input signal results in an identical time shift in the output signal. So what it means that suppose we have a system in which output is denoted by yn and input is denoted by xn. So if we shift our input by amount, suppose we are shifting it with amount of n naught, then output should also be shifted by that same amount. Then we can say that our system is time invariant. And similarly for the continuous time case, if the output is denoted by yt and input is denoted by xt, then shifting your input by an amount t naught will shift the output with the same amount. Then we can say that this is a continuous time system and it is time invariant. So this is the basic definition of time invariant system. Now we will understand the concept of time variance and invariance with some examples. So we'll take example 1. So we'll are taking a system which is defined by yt is equals to sine of mod of xt. So to check this system is time invariant, we must determine whether the time invariance property holds for any input at any time shift t naught. So what we'll do, we'll first take an input x1t. So for x1t, what will be y1t? y1t will be sine of mod of x1t. Okay. And now we'll take a second input which is x2t, and that is a shifted version of your previous input, that is x1t. So x2t will be x of t1 minus t naught. Now the corresponding output, how it will look like, then y2t will be sine of mod of x2t. And suppose we mark it as equation number 1, it is equation number 2. Now from equation 2 we can write that this is sine of x1 t minus t naught. Okay. Now from equation 1 we can also write the shifted version as y1 t minus t naught is equals to sine of x1 t minus t naught. And now you can see that the equation 3 and equation 4 signifies that y2t is y1 of t minus t naught. So what is happening here? If we apply an input which is a shifted version of our input signal, we'll get an output which is also the shifted version of the output signal with the same amount. So it is also a shifted version of the same amount t naught. So this means that the system is time invariant. Now we can have a different example also. So we can take an example 2 in which we have a system which is described by yn is equals to n of xn. So again we'll do the same procedure. So what we'll do, we'll take an input x1n, corresponding to it the output y1n will be equal to n of x1n. Now we'll take an x2n which is the shifted version of your x1n. This implies that the output y2n will be equal to n into x2n, and from this above equation, and again we'll name them equation number 1, equation number 2. So from equation number 2 we can write it as n into x1 n minus n naught, and this is equation number 3. And from equation number 1 we can directly write that y1 of n minus n naught will be n minus n naught into x1 n minus n naught. And you can see that equation number 3 and 4 are not identical. So y2n is not equal to y1 of n minus n naught. So this signifies that the system is time variant. So shifting your input by an amount of n naught will not leads to the shifting of output with the same amount. So that's why the system is time variant. So this is all about time invariance. In the next lecture we will see the linearity property of a system.